Hello viewers, welcome to Chemistry Online class. So on today's class, we want to solve question 1 of NECO Chemistry Practical 2025. So this is the question. So follow me as we solve the question. And it says A is a solution containing 6.3 grams per EM cube HNO3, which is nitric acid. And B is a solution of 8.0 grams mixture of Na2CO3, that is sodium carbonate, and NaNO3, that is sodium nitrate, in 1000 cm. So this is a acid-base titration. And in this acid-base titration, B is a mixture of sodium carbonate and sodium nitrate. So this mixture is an impure mixture because sodium carbonate is a strong base, while sodium nitrate is not a base, rather is a salt. Okay, now we have our A, which is what nitric acid. So it says titrate A against 20.0 cm cube or 25.0 cm cube portions of B using methyl orange as indicator. Repeat the titration 3 more times and record your results. Okay, volume of pipettes used. So you need to do or state the volume of pipettes used. Okay, now after our titration, this is what we got. This is our table of what? Reading. We have our rough, first title, second title, and third title. Okay. Now the volume of pipettes we use in this titration is 25.0 cm cube. Okay. Remember, they said you should choose either 20.0 or 25.0 cm cube. The one we use is what? 25.0 cm cube. And we have what? Our table of reading. We've done the titration already, and this is our table. Now the question says, calculate the average volume of A used. Okay, we are asked to do what? To calculate the average volume of acid used. Average volume of acid used. 1AII says, is the pH of the following solution 7, greater than 7 or less than 7? That is solution A before the titration, solution B before the titration, solution at the end point. Now, this is the equation of the reaction. We have the atomic mass of the element present in the compound. Now, question 1b says, from the results and information provided, calculate the I concentration of A in mole per dm3, concentration of sodium carbonate in mole per dm3, concentration of sodium carbonate in grams per dm3, percentage of sodium carbonate in B. Now, what he says, why did sodium nitrate not take part in the reaction? Okay, now let's start. The first question says that we should calculate the average volume of A used. Okay, the average volume of A used. But before that, let's quickly answer this one. Is the pH of the following solution 7, greater than 7, or less than 7? Okay, we all know that our solution A before the titration is nitric acid. Since it is an acid, a pH scale is a scale we use to determine the acidity and alkalinity of a substance. So since A is an acid, is HNO3 less than 7, you can say it was acidic. Then the second one, solution B before the titration is greater than 7 because it's a base. Okay, now solution at the end point, that is neutralization has occurred, so it was equal to 7. Okay, that's NaNO3. Okay, now back to the question A. I calculate the average volume of A used. Okay, let's quickly do that. So this is our table. We are asked to calculate the average volume of A used. So we are going, this is our rough. We have a first title, second title, and third title. So average volume of A used is equal to our first title is 26.30 plus our second title 26.20 plus our third title 26.10, all divided by 3. So which is going to give us 26.20 cm cube. So this is our VA, average volume of A used. Now, the second question says concentration of A in mole per dmq. Okay, concentration of A in mole per dmq. Now, the concentration of A is given to us in gram per dmq. The concentration of A is given to us in grams per dmq, that is 6.3. Now, let's do it. So we have gotten our average volume of A, which is VA equals to 26.20 cm. Now the next question says that we should calculate the concentration of A in mole per dmq. So and we have A, concentration of A in grams per dmq. So concentration of A in mole per dmq is equal to quantity of A in grams per dmq divided by molar mass. Okay, and molar mass of A given to us is 63 grams per mole. So what we are going to have is in gram per dmq we have 6.3 divided by 63. Okay, which is going to give us 0.1 mole per dmq. So we have gotten our concentration of A in mole per dmq, which is 0.1 mole per dmq. Now the next question says that we should calculate the concentration of sodium carbonate, in mole per dmq. Okay, concentration of sodium carbonate in mole per dmq. So we have this is 1 BII conc of sodium carbonate in mole per dmq. Okay, we are going to use the general formula CaVa divided by CbVb equal to NaNb. Okay, now we have our Cb is equal to CaVa times Nb divided by VbNa. Okay, when we substitute, our Ca is equal to what? 0.1 times our volume of A, which is 26.2 times. This is a mole ratio from the equation of the reaction, sodium carbonate reacting with nitric acid. The mole ratio so from the equation of the reaction, this is the equation of the reaction. Okay, we want to find our Na and Nb. This is sodium carbonate, which is our B, and this is nitric acid, which is our A. So it means that Na is equal to 2 mole ratio and Nb is equal to 1. Okay, now back to the formula. By our Vb, that is volume of pipette used, we use 25 cm, 0.0 cm times our Na is equal to what? Our Na is equal to 2. So when we multiply and divide, we are going to have our Cb equal to 0.0524 mole per dmq. Now the next question says that we should calculate the concentration of sodium carbonate in grams per dmq. The concentration of sodium carbonate in grams per dmq. Okay, we have gotten it in mole per dmq. So in gram per dmq, we are going to have okay, so the concentration of sodium carbonate in gram per dmq is going to be equal to molarity times molar mass. Okay, molarity is also as concentration of this in mole per dmq. So when we the molar mass of this sodium carbonate, let's calculate the molar mass. Molar mass of Na2CO3 is equal to, just to add their atomic mass, we have 23 times 2 plus 12 plus 16 times 3. Okay, we have 48 plus 12 plus 43. Okay, which is going to give us, when we add, what are we going to have? We are going to have 106 gram per mole. Okay, now we carry this to this formula, which is going to give us our molarity. We have 0.0524 times our molar mass, which is 106. We are going to have our concentration in gram per mole as equal to, what are we going to have? We are going to have what? 5.5 grams per dm cube. Okay. Now the next question says that we should calculate the percentage of sodium carbonate in B. Remember that B is a mixture of sodium carbonate and sodium nitrate. Now the question says calculate the percentage of sodium carbonate in B. Okay, meaning that B is an impure solution or impure mixture. Okay. Now, formula for calculating percentage purity is equal to mass of pure substance divided by mass of impure substance multiplied by 100. Okay, from the question, mass of pure is the mass of sodium carbonate in gram per dm cube. So we have it as 5.5 divided mass of impure is the mass of the mixture, which is 8.0. So we have 8.0 times times 100. So when we divide, what are we going to have? We are going to have 69 point what? 43%. The last question for number 1 says, why did sodium nitrate not take part in the reaction? Okay, sodium nitrate is a salt gotten from reacting a strong base and a strong acid. Sodium nitrate is a salt. That's why it did not take part in the reaction. Okay, see you in my next video. Stay tuned as we continue from number 2.